All right. So we are going to keep going with three-dimensional coordinates. So we're still in section 11.1 when you go to do your homework. Okay. But we took up a lot of time making our three-space figures. So I didn't want to push it with this other stuff. So we're going to have a short lesson and then you'll get to work on some homework. Maybe I'll even share some of our graphs that we've done. Okay. So midpoint. How do we calculate the midpoint if we're in 2 dimensions? Like if I had the coordinate 1, 2 and the coordinate 5, 9, how do we figure out our midpoint? Maybe chat about it with a neighbor for a moment, huh? So I've heard a couple people say the right thing. How do we do it? Kylie, how do we do it? Okay, we add the x's, divide by 2, add the y's, divide by 2. Hey, guess what? In 3 dimensions, it's just one more dimension. Add the x's, divide by 2, add the y's, divide by 2, add the z's, divide by 2. While we're kind of wrapping up writing this down, if you have a textbook, it is something that you will have to turn into me. So if you've just been using the Google Classroom PDFs to do your homework, go ahead and bring your book in like tomorrow. That way you can just get it over with. If you're still using those PDF links, or if you're still using your physical book, that's fine. You'll be able to bring it to me on Tuesday. But if you forget it Tuesday, then it's kind of a mess. So think about whether you're ready to turn that in or not, okay? All right, so let's find the midpoint between these 2 coordinates. Write them down and write down the work that you think will lead to the answer. Okay, so our midpoint, we're going to add our x's, divide by 2, add our y's, and divide by 2, add our z's and divide by 2. So our midpoint would be, help me out, -1, 0, 7.5, 15 halves. Don't really care how you write it. Well, I do care. Don't do a mixed number. Either 7.5 or 15 halves. Do not write 7 and a 1/2. Okay. All right, can you handle that? Awesome. Okay. In 2 dimensions, we have a circle. In 3 dimensions, it becomes a sphere. Okay. So we're going to talk about the standard form of a sphere. Okay. It's very, very similar to that of a circle. We just have a 3rd dimension. Okay. So we have x minus k squared plus y, x minus h squared plus y minus k squared plus z minus j squared, but it still equals r squared. I know that it's really tempting to want to put r cubed because we're in 3 dimensions, but it's still r squared because we're still based off of some of that Pythagorean geometry. Okay. So we have a center and a radius. Here's the standard equation. This is our last normal Thursday. His finals are Wednesday, Thursday, Friday.
I forget on Thursday.
No, we get out on Friday. At 11:15 though.
Yeah, it's a short day.
Yeah, I mean, you have 3 short days. You have lunch Wednesday and Thursday, but you don't have to eat lunch here. There is no lunch here on Friday. So, okay, so we're gonna start simple. What is the equation of a sphere with a center at, write it down, 2, -4, 3, and a radius of 3? Okay, so on the screen previous, this is what we wrote down for the standard equation of a sphere. So if we have a center of 2, -4, 3, then we are going to write x minus 2, the quantity squared. Y minus -4 is just going to be us writing y plus 4, the quantity squared. Z minus 3, the quantity squared. And if our radius is 3, what would we have on the right side of our equation? 9. Okay. Now, the probability that I give you a question this straightforward on the test, pretty small. Okay. What kinds of things may I ask you to do with, or could I ask you to do with equation of a sphere? So here we go. Here's a little bit more exciting of a problem. I'm telling you that the sphere has endpoints of a diameter at 5, 2, 1 and 1, -4, 5. Okay, so first, I want you to just think for a moment, okay? In order to write the equation of a sphere, we need the center and the radius. Right now, we have neither one of those things. But I want you to think a little bit silently about how we might be able to figure out the center and the radius. And if you could for me, turn to a neighbor and just verbalize your thoughts for a moment. How are we gonna figure out the center and radius? Okay, what's true about a diameter? It goes through the center. Okay, so Darby, how might we find the center? We can totally do the midpoint of our endpoints. Okay, so for our center, we could find the midpoint of these two coordinates. Okay. All right, so our center would be at what? 3, -1, 3. Do you agree with that? Okay, thank you. Okay. All right, so we have the center. How do we figure out the radius? We have 2 options. We can use the distance formula. Now, we can use the distance formula from endpoint to endpoint, but then we'd have to cut that in half. Or now that we have the center, we can find the distance from midpoint to endpoint. Which one sounds better? Yeah, let's go from the center to the end, okay? So our radius, let's spell correctly, is going to be the distance between, doesn't matter which one we pick. No, so let's take the center and this one because it has all positive numbers. I don't know. So the square root of 3 minus 5 squared plus -1 minus 2 squared is 3 minus 1 squared. Okay. And so far, we really haven't needed our calculator to approximate anything. Whoops, sorry. So what? This gives us +4 + 9 + 4. So we have the square root of what? Right, because we have 4 + 9 + 4. Okay. So when we go to make our equation, we're going to have x minus h squared plus y minus k squared plus z minus j squared equals r squared. We could just write what number? 17. So don't freak out about that radical. It's going to be okay because when we square it, it goes away anyway. Okay. Now, on a problem like this, it was really nice to find the center first because then we could use that to help us with our radius. If you tried to find your radius first, you would have done the distance between the endpoints and then you would have had to cut that in half. It's fine, but it's probably just as easy to just keep it, find that center first and then go from there. Okay. All right. So one last thing I want you to be able to do. This is going to be kind of a throwback to chapter 10A, which luckily you had to prepare for your final. So you've done this in the past couple weeks. I want to find the center and radius of this sphere. So go ahead and write down this equation for me, please. Okay. And if we need to identify the center and the radius, how should our equation look in order for us to be able to do that? Should it look like this? No. Should it look like this? Yes, if we have it in standard form, we can identify the center and the radius. So since this is not in standard form, what algebra trick do we get to use 3 times? Completing the square. All right, so I'm gonna write x squared minus 2x plus blank plus y squared plus 4y plus blank plus z squared minus 6z plus blank. And then I'm going to subtract that 8 over, and we're going to have to add those same 3 numbers to the right side that we're adding to the left side. Now, like I said, luckily we've done this in the past couple weeks, so shouldn't be too terrible. What number completes the square right here for our x's? What did you say? You said 1. Okay. I thought you said 1. But then I wasn't. Okay. How about for our y's? 4. And everybody, let's all say it together. What completes our square for the z's? 9. 3 squared is what he was thinking, right? Okay. So we have x minus 1, the quantity squared, plus y plus 2, the quantity squared, plus z minus 3, the quantity squared, equals 6. Okay, now, I mean, I sort of care about that, but what I really want is the center and the radius. So we need to pick out that our center is at 1, -2, 3, and our radius is 6. The square root of 6. Remember, this is r squared. So the square root of 6 will be our radius. And that's all I've got for you. Okay, so you have 20 minutes. I bet you can finish, not only start, but finish your homework assignment.